Welcome back. As discussed earlier in this MOOC, the output of a PV system is fed into an electricity grid or an electrical power system. In this video lecture, we will discuss how electricity can be carried to the consumers via an electric power system. The learning objective of this video lecture is to understand the important aspects of an electricity grid or electrical power system, such as the three main system components it consists of, like generation, transmission, and distribution, and how the future electricity grid will be different from the traditional electricity grid we know currently. So what is a power system? And what are the main parts and functionalities of a power system? Let's have a look at a representation of a traditional power system. A traditional power system consists of three main systems: the generation, the transmission, and the distribution system. We call it traditional because generation of electricity is centralized, meaning that only a few large power plants are involved. The generation system comprises the power plants that supply power to the system, also called the generation stations or generation units. Some examples of traditional power plants are the thermal one, the hydro, and nuclear power plants. The transmission system is made up of transmission lines that transport the power from the generation system to the distribution system. Typical voltage levels for the transmission system range from 10 kV up to 1100 kV. The distribution system is the network that feeds the power to the load. The load represents the power consumption of the system. It contains households, hospitals, commercial buildings, and small to medium-sized industry, among others. Typical voltage levels for the distribution system go from 120 volts up to 10 kilovolts. The voltage levels of the transmission system are higher than those of the distribution system. You might wonder, how does a voltage level change from one system to the other? In power system, this is done mainly by means of transformers. A transformer uses electromagnetic induction to transfer electrical energy between two or more circuits. A typical transformer consists of two windings. Depending on the ratio between the primary and the secondary winding, the voltage will be increased or decreased. Transformers are generally placed at substations. A substation contains many elements that are important for keeping the system operating between the admissible boundaries. Some of these elements are the transformers, capacitor banks, switches, circuit breakers, monitoring equipment, among others. In short, an electric power system is a network used to supply, transport, and distribute electric power to the loads. Let's have a closer look at the diagram. Notice the direction of the power denoted by the arrows. As you can see, there is an unidirectional power flow, which means that the generation occurs only at the generation side of the power system and consumption only at the distribution side. This is one important characteristic of the traditional power system, but there are some other characteristics that are worth mentioning. For example, most power plants are controllable and the large voltage is increased or decreased by means of transformers. Large power plants operate on alternating currents. Let's now have a look at how a future power system could look like. Please notice the differences. First, you might observe that there are generation units located at the distribution system level. They are not centralized as in the case of traditional power systems, but distributed. This is known as distributed generation. Some examples are photovoltaic panels, small wind turbines, and fuel cells, for instance. As you can see, the power flow not only goes from the generation system towards the distribution system, but now there are power flows going in the opposite direction as well. This occurs as a result of distributed generation, particularly in the case when more power is generated than consumed. You might have also noticed the presence of large consumers such as electric vehicles, and also the presence of intelligent nodes, or in other words, nodes in which smart grid concepts will be enabled. You have probably heard the concept of smart grids before. A smart grid is an electricity network that can intelligently integrate the actions of all users connected to it in order to efficiently deliver sustainable, economic, and secure electricity supplies. The word intelligently means that the power system employs monitoring, control, communication, and self-healing technologies to enable a power balance between generation and consumption. Let's summarize some of the main characteristics that power systems will likely have in the coming future. First, a high percentage of power plants will be driven by uncontrollable sources as opposed to the controlled centralized power plants mostly driven on fossil fuels. Secondly, a considerable percentage of generation units will generate direct current as opposed to the large power plants which generate alternating current. Additionally, a considerable number of generation units will be based on renewable sources and will be of small scale located at the distribution system. There will be a bidirectional power flow, for example, when more power is generated at the distribution system than consumed. Storage will play a major role due to uncontrollable sources. Finally, smart grid concept will be introduced to balance generation and consumption. In summary, in this lecture, we have discussed the main parts of a traditional power system, and we got an impression of how the power system of the future could look like. In the next video, we will discuss some operation issue of the electricity network, like the frequency control of an AC network, and what happens if renewable electricity generators like photovoltaics are introduced. So, see you in the next video.